Uh, well, isn't it the time to start the session already? Okay. So welcome everyone to this first session of RPA Forum. It's nice to have you here, even though it would have been nicer to meet all of you physically in Sevilla. So my name is Nina Helander. I'm Professor of Information and Knowledge Management, and I work at Tampere University in Finland. So we have here rainy and windy weather, so it would have been nicer to be in Sevilla. But I'm co-hosting this session together with Dr. Amador Duran. So Amador, would you like to say a few words about yourself?
Of course. Well, my name is Amador Duran, as Nina has said. I work in the Applied Software Engineering Research Group with Christina and most of the organizer of this conference. And it's a pleasure to be here with you. Well, of course, I work at the University of Seville. I haven't said that, but it's not rainy and it's not windy here. It's a little bit cloudy, but it's still hot. We are at the end of summer.
Okay, so thank you, Amador. So we are having 5 very interesting papers in this session, and we already have all of our presentators here. And so we have Simon as the first presenter, and Amador, I think you would like to introduce.
Okay. So the first presentation is presented by Simone Agostinelli from the Sapienza Università di Roma in Italy. And it's called Automated Generation of Executable RPA Scripts from User Interface Logs. So Simone, when you want.
Thank you for the introduction. I share my screen. Do you see my screen?
Yes.
Yes.
Okay, let's start. So today I'm going to present our work entitled Automated Generation of Executable RPA Scripts from User Interface Logs. What is robotic process automation? Robotic process automation is a technology that allows to replicate repetitive routine tasks in place of human users by the enactment of software robots. One of the major problems that is affecting the current generation of the RPA tools is that they are driven by predefined rules and manual configuration made by expert users rather than automated intelligent techniques. So, for this reason, there is the need to skill a human worker to understand the anatomy of the routines to automate by means of interviews and observation, and also to manually model the flowchart diagram representing the structure of such routines. So for this reason, the current practice is time-consuming and error-prone. In order to mitigate, in order to tackle this challenge, our research objective is to automatically develop the software robots directly from the user's observed behavior, without the manual intervention of the human users. So we envision a 3-steps approach that allows us to train the RPA routines based on the observed behavior stored in dedicated user interface logs in order to automatically find the best way to perform a specific routine. The second step is to abstract the events to a high level from a low level one, thus skipping completely the manual modeling on the flowchart diagrams. The third step is to implement and enact the software robot emulating the most frequent routine reflecting the observed behavior within the user interface logs. Looking at the current state-of-the-art approaches, we categorize them into 3 groups. The first group is by means of observation. So by means of observation, it's possible to derive the behavior of software robots. The second category is by means of natural language description. And the third category, which is the least measured but the most promising one, is by reinforcement learning techniques. So here in this slide, we can see the conceptual architecture of our tool that is called Smart RPA, and it is made up by 5 different components. The first one is the action logger. The second one is the log processing component. The third one is the event abstraction component. The fourth one is the process discovery component. And the last one is the RPA component. But before going through all these architecture layers, it is worth to notice that we tested and validated the tool with 25 different users that are instructed to fill a Google form using the data from an Excel spreadsheet and containing the personal information for the people who want to go for a travel. In our department, the professor, the researcher, and the PhD student has to fill a spreadsheet info and send it to the administration employee. Then the administration employee has to copy and pass the personal information of the people who want to go to a travel into a Google form. Smart RPA is able to automatically develop the RPA scripts for automating the data transfer of this routine. So our goal was to automate this routine as a case study. Here we can see an example of the form. On the left, we can see the Excel module, and on the right, the Google form that the administration employee has to fill. So let's start with the walkthrough. The first component of our tool was the action logger. The action logger is made up by 3 different logging modules. The first one is the system logger that allows us to record the user action that are happening on the user interface of a computer system, such as the click, the creation, and the deletion of the folder, and so on and so forth. The second module is the Office logger that allows us to capture the user actions happening on the Microsoft Office suite. And the third logging module is the browser logger that allows us to record the user action happening on Firefox, Google Chrome, Microsoft Edge, and Opera. All these user actions are sent to a login server that is in charge to store this action as events. In our example, since we had 25 end users, at the end of this phase, we had 25 CSV event logs. Here we can see an example of the graphical user interface of our tool, on the left for Windows system and on the right for macOS based systems. Here we can see a small video of our action logger in action. And as we can see, the user is copying and pasting the elements from the Excel file to the Google form, and the action logger is currently listening and recording all the user actions happening on this form. Then the user clicks submit, and everything is fine. So the second component of our tool is a log processing tool that has goal to merge all these event logs into one data frame. So in our case, since we have 25 CSV, at the end we will have one data frame with 25 execution traces. In this slide, we can see an example of our data frame, which consists of 45 different columns, but for the sake of space, we show only the most important one, such as the timestamp, the results who executed the activity, the category of the application, and so on and so forth. Here we also see the XCS file coming from the data frame. So the tool is able also to export the data frame into the XCS standard, the standard for process mining. And on the left, we can see that we have the 25 variants, that is the 25 routine traces. The third component is the event abstraction component that allows us to transform the data frame containing all the low-level events into a data frame with high-level events through 3 different steps. The first step is to filter the relevant events, for example, the resize of a window, the moving between the different tabs of the Google Chrome that are relevant from the RPA analyst perspective. The second step is to group similar events. For example, different low-level events can be mapped to a single high-level one. And the third is to create descriptive labels for the low-level events. Here, an example of event abstraction. We start, for instance, to the edit cell low-level event, and we come up to an high-level one, for example, edit cell B12 on sheet 2 with the value test. The output of the event abstraction component, that is a data frame in the form of an high-level one, is the input of the process discovery. In particular, the process discovery component has twofold objective. The first objective is to infer the process model from the high-level event log, as we can see in this slide, and the second one is to find the most frequent routine from the low-level data frame. And in our case, we had 25 routine traces. We grouped them by the leverage and distance, and we found out that 7 of them are similar by at least 90%. Among the 7, we picked the shortest one, and this is the most frequent routine. The last component is the RPA component, but before the enactment of the software robot, the user is prompted out with the choices dialog that allows to enact the several variants of the same routine, changing the input value, as we can see from the slide. Here we can see an example of executing the RPA script because after the choices dialog, the script is generated according to the operating system in which the tool is running. Here we can see the video. In the video, we can see how the script is running and is able to replace all the user action that did the administration office, and everything is fine. So in conclusion, we automatically develop software robots directly from the user's observed behavior without the manual intervention of the human user. Smart RPA provides a general purpose action logger that allows to make auditable the logs, since they can be inspected. We perform an high-level event abstraction by looking at the flowchart of execution, and Smart RPA automatically selects the most frequent routine to automate and generates cross-platform executable RPA scripts. Our tool allows also the possibility to run the scripts also on WePath, which is one of the major vendors in RPA. However, our work has a limitation. The first one, we would like to support the subroutines, that is, instead, rather than picking the most frequent routine, it is useful to execute the routine fragments, the most suitable routine fragments at runtime, depending on the input value. Another future work that we would like to extend is the support for segmentation. That is the challenge to understand which user action contribute to which routine. So, just to conclude, I would like to emphasize that our long-term target is in line with one of those identified challenges by Mo Win in the yesterday keynote. That concludes our presentation, and thank you for the attention.
So,
thank you very much. We can give the applause now.
Okay.
okay, now we're supposed to pass to the questions. I'm not sure what I have to do. Where can I see the chat? Okay. I think maybe you should stop sharing your screen.
Okay.
So we can go. Okay, so we can go back to the view where we can see everyone's faces. And for the moment, there are no questions on the chat. I cannot see anyone raising his hand.
There is one question.
Yes,
the
where?
Q&A panel.
And the
Q&A.
panelist.
What is the question?
I cannot see it, Nina.
Yes, Andres raised his hand. Andres Jimenez.
Oh, all right. So, okay, Andres, I'm going to let you speak. Right, try it.
Hey, can you hear me now?
Yes.
Yes, yes. I can hear you.
Sorry, I wrote in the Q&A. It's okay. Nice work, Simon.
Thank you very much.
It's really nice. I asked many questions, but just one. Your action logger is, as far as I understood, is for only logging one case, or you can, for example, log 2 hours of interaction with the tool, and then in the following steps you divide by cases.
I can record many cases, but of the single routine. I can record the different routine execution, but the routine is always one, but the cases are different.
So my question is then, how can you separate them? What's the procedure you follow to do that?
I separate the cases by the training session because each training session is separate from the other, and as a consequence, all the cases are separated.
So you mark during runtime when a case starts. Huh?
Yes.
Okay, but we also, just to get an idea, because that implies some manual work, right? So you have to do it manually during the sessions.
I don't know if I understand correctly your question, but the case is not manually because in the code we have the timestamp of that case. So I don't know how to explain myself, but the cases are different.
Yeah, probably I can elaborate a bit more. For example, if you have to put some data in a web form using the data that is from the Excel file, right?
Okay.
But when you finish filling the form once and you push submit, then you do again.
Yes.
With the next data from the Excel. So my question is
yes, but it is another CSV event log. Okay.
So you did that's the answer. Thank you. So you just differential different CSV. Okay.
Yeah.
Thank you. Any other question?
I think Andrea has here something to add.
Can I talk?
Or can I see it right in the chat?
Yeah.
Can I intervene to answer? Andrea, if you raise your hand, I can see you on the list, Andrea. Okay, now you can talk.
Okay, can you hear me?
Yes.
Yes.
No, just to answer to, I am one other author of the paper, just to answer to the question of Andreas. So with the action logger, you can record whatever you want of the system, of course. So you can record also days of interactions. By now, let's say what is missing in the tool is the segmentation part. So the fact is that the idea you have to train you have to ask to several users to execute just a specific routine in various ways. So you already know that in the log you are recording the user action related to that routine. Okay, so of course this requires some manual work at the beginning. But as Simone has said, let's say the next step is to develop this segmentation algorithm that will allow to start from a complex log with several routines recorded and identify these routines automatically. I think that this was the point raised by Andreas. That's it.
Okay, thank you, Andrea. So I think it's the time to pass to the next presentation. Do you think, Nina? Because it's more than...
Yes. Yes. So
thank you, Simone, for your presentation and your answers.
You're welcome.
Yes, thank you. And yes, let's move on to our second presentation. It's a paper written by Maximilian König, Leon Bain, Adriatic Nikai, and Matthias Weske. And we have Leon here to present the paper. So please.
Yeah, hello. Thanks for the introduction. Welcome, everyone. I'm Leon. I'm a master's student at the Hasso-Plattner Institute at the University of Potsdam. My fellow master student Max and I worked on the topic of integrating robotic process automation into business process management, and we are happy to have this opportunity here to present our work to you. So first of all, why would we want such an integration? RPA in its core, we have heard this already, means automating tasks that consist of UI interactions. We use software agents, so-called robots here, that assume these UI interactions. However, RPA is limited in its scope. So while it does provide an approach to automate tasks, it does not define how to embed this approach into a bigger business scope, into a context. RPA does not specify how to obtain the process knowledge that is needed to identify and implement the RPA routines. RPA is not applicable when tasks in a business process just are not composed of human interaction with UI. So this might be tasks that include physical work, that include highly complex decision-making, but also tasks that simply do not involve humans at all, but just consist of API calls or similar. Orchestrating sub-processes on a large-scale end-to-end process level is also not in the scope of RPA. RPA usually aims at automating tasks or smaller processes, but we want to give this context actually to the routines, to what RPA does. When errors or in general situations that a robot does not know how to act are encountered, the robot needs to contact a human. And while there already exist solution approaches, like sending emails to a dedicated supervisor, the overall process perspective is not considered here. So we don't have the means to define what impact such an error has on the overall process state or system state. And finally, there is the topic of resource management, which I think we can all agree it's a whole research topic on its own, and it's very important for efficient process optimization, but further than managing robots, it's not taken care of by RPA. So with all those limitations in mind, we noticed that processes with RPA routines in it can still be considered business processes, right? So this allows us to resort to business process management, and business process management includes the tools and methods to exactly deal with all those problems. So what does business process management give us? The first thing that BPM provides us is a proven methodology. This methodology is usually centered around the business process lifecycle, which, depending on which definition is used, has the following phases. So we have a design and analysis phase, where processes are identified and modeled, they are validated, and given previous iterations, existing processes are redesigned. In the configuration phase, the processes are implemented, all systems are set up, and everything in general is made ready to launch. Then in the enactment phase, we operate and maintain the processes, and we can monitor the performance to gain insights for later evaluation, which is done in the evaluation phase. We can use techniques such as process mining here to evaluate the performance and find leverage points for improvement. So overall, with this methodology centered around this life cycle, we can obtain in-depth process knowledge, we can embed processes into a bigger context, and we also gain access to further techniques such as case management or decision management. In addition to the methodology, BPM provides a standardization for processes through notations like BPMN. So this does not only allow us to communicate about processes, but it also provides us concepts for control flow, process escalation and composition, for the execution of different task types, or for handling business errors. So these are all things that help us give context to the RPA routines. And lastly, BPM comes with the technology to automate business processes on a high level. So we have BPM systems that are mature software that much work has flown into, and they support the execution of the BPMN constructs or whichever notation is used. They support resource management, but they also support error handling or monitoring that we can all use for RPA. So we have this big motivation to use this arsenal for RPA and to integrate RPA into this ecosystem. And the question now is, how do we do that? And our approach was to follow the observations that these RPA processes are just business processes. And therefore, we tried to apply the BPM methodology to those processes again. What we did here was to take the BPM lifecycle, look at each phase, and adapt the phases to the needs of RPA routines. And afterwards, we take these adapted phases and reintegrate them back to the BPM lifecycle, so we get some kind of RPA-aware BPM lifecycle. The phases look very similar to the BPM phases, but what is important here is that we can use the artifacts from the BPM ecosystem that surrounds the lifecycle for our RPA routines. So in the design analysis phase, we identify and model and formalize the RPA candidates, but we can use the information that we need for identification and formalization from the BPM ecosystem. We can also give context to the processes, so the connections to other business processes, the process in and outputs from the surrounding BPM methods. In the configuration phase, we select the RPA systems, we implement the routines, we deploy them, we test them, and here we can share the infrastructure between the RPA systems and the BPM systems. So if we have servers where the systems are running, we can share those servers. Additionally, which is really important, we can embed the implementation of the routines into the business process implementation. So there are points in business processes where the routines are called, and we automate this. So we actually embed the implementation into the business process implementation. So in the enactment phase, we can also execute those routines embeddedly. So there's no human interference needed to start the routines, but they are started by the BPMS at the point when the point in the business process is reached where the routine should be started. Additionally, we can use the monitoring and error handling capabilities that the BPMS provides us to further give more insights to the execution of our RPA routines. And this data can then be used in the evaluation phase to evaluate how our RPA routines performed. So maybe to find leverage points for improvement, but also to close the cycle, we can find points where we want to apply RPA and start the cycle over and over again. So summing up with this approach, we gain, with reintegrating these phases into the BPM lifecycle, we gain a method where we can use the full power of BPM around our RPA routines. And that is quite a powerful thing. In the next step, we want to have one closer look at the embedded execution, because while it's already possible to embed the RPA execution into BPM execution by using API calls and similar, we didn't like the way it was done, because implementation details, so the details how to access the RPA system, are leaked into the BPM, into the business process implementation. And for us, the goal was to make implementing an RPA task, so to say, feel like a service task. So only the in and output should be specified, and the ID of the routine that is to be executed, but nothing more. And what we did for this was to integrate also the system architectures. Let's have a short look at the system architectures. On the BPM side, generic architecture looks like that we have processes that are defined and then deployed to an engine, and this engine executes the process instances, interacting with process participants, human participants, but also with external applications that help with the execution. And similarly, we define a generic RPAS architecture where the routines are defined, deployed to a controller, and this controller can be accessed by an operator API to start routines, and then these routines are deployed to robots that execute those routine instances. So we have two linking points, in one on each side. On the BPM side, we can plug in new applications that can be invoked to delegate the execution of tasks to. And on the RPA side, we have the operator, which can act as API to start new routines from a software side. And what we did was to introduce a third component, a small bridge system in between, where we have a BPM adapter that acts as invoked application that takes all the inputs and the routine that has to be run. Then a core system that governs the execution of the routines, that calls different steps for the execution. And then an RPAS adapter that translates these calls into API calls. So the operator on the RPA side knows what to do and which routines to start. The routines are then executed on the RPA side, and results are passed back through the bridge system. What do we achieve with this architecture? Well, first of all, we do not leak the implementation details, because a process designer can just call RPA routines like service tasks, because the BPMS adapter acts as invoked application. Secondly, what was important for us was to have some kind of separation of concerns. So each system should do what it is designed for. An example for this is how resources are managed. So robots are not seen as general resources, but are rather managed by the controller, so on the RPA side, while general resource management is done by the process engine on the BPM side. And lastly, we achieve some kind of vendor independence. So we can support different vendors by changing the adapters, because these are simple interfaces that can be switched in and out, and just the core system stays in place. So to wrap this all up, we can say that RPA and BPM are quite a good match from our perspective. BPM helps to cope with the RPA limitations and provides useful tools and methods to give context to the RPA routines. We can integrate RPA and BPM methodologically. We did this with a resulting RPA-aware BPM lifecycle. They can also be integrated on a system architecture level, which resulted in a bridge system for us, which, if you're interested, can be found on GitHub in an example implementation. In the future, empirical studies regarding the application of our approach should be conducted. So we want to see the reality, how it really works. A more detailed formalization should be developed. So especially the impact on an organizational level should be looked at. And we are eager to hear what your thoughts are, what should be done with this work. And thank you very much for your attention.
Thank you very much, Leon. And I think we can now give the applause. So, could you, Leon, please stop sharing the slide so we can see the chat box. So please, if you have questions or comments to Leon, you can either write in the chat or just raise your hand.
Can I ask a question, Hina, if possible?
Sure.
Leon, I just have a very simple question. Thank you very much for your presentation, and I think it's definitely a match made in heaven between BPMS and RPA. My question is about your focus. Did you also consider unattended bots in your experiments, or you were only looking for the attended bots?
That's a good question, because we really don't really have the concept of attendance here, because if we say that so it's more on unintended bots actually, because we want to reduce the human interference when calling the RPA routines to a minimum. So the BPMS calls the routines, and the routines are run ideally on some server infrastructure, but usually I think without, the idea is without supervision, without human supervision.
All right, thanks.
Okay, thank you, Rehan, for the good question. You, Leon, are getting also some very positive feedback in the chat. I also agree with Roger, and we thank you, Leon, for the great presentation. And as Rehan also told, I think this is a match made in heaven. And I think there are many good areas where you can apply this, but I would like to ask from you that, do you have been thinking the different contexts where this kind of approach could be used? Are there some limitations, or what do you think?
Yeah, so one limitation what we didn't like about this approach was that it's really heavy focused on the BPM. So we might miss an opportunity to do things that are really RPA specific and that are really good tailored to RPA. We kept this very generic. So it would be really interesting to see this in action, to see this applied, and then really see where it works and where it does not work. So this is future work, so to say.
Yes,
but
thank you.
From our perspective, it aims at companies that maybe already have business process management running, so it's not setting up two systems at once. And I think they can profit greatly from such an approach.
Yes, I think so too. And I think it would be very nice to hear maybe next year your empirical research results, if you are able to apply this in some of those companies.
We will see.
Yeah, thank you. So are there some other questions, or?
I think somebody's raising their hand.
Yes, Roger, please. I think.
Yes, hello. Can you hear me?
Yeah.
Yes, we can hear you.
Yes, hi Leon. Thank you for a great presentation once again. I have a question about the part that has to do with process discovery, both in the contexts of BPM and RPA. So my question is, do you see that there is one approach to process discovery that is suitable for both processes that are found at the BPM level and the RPA level, or do you believe and see that there is more than one approach for process discovery for those types of processes? Thank you.
So I think that's a good question. I think our idea was mostly to apply the BPM discovery approaches to RPA, because we think that those are really mature. There's a lot of work on process discovery in the BPM field. And on the other hand, we usually know the criteria for RPA processes, so that they are repetitive and time consuming. And I think we can derive this information from whatever approach is used from the BPM methodology. So we can use different approaches, surely. But yeah, again, we are coming strongly from the BPM perspective. I'm not sure if this answers your question.
Yes, indeed. Thank you.
You're welcome.
Okay, thank you very much. I think we have used now our discussion time. So once again, thank you, Leon, for the great presentation and for the great answers. Now let's move on to the third presentation. So Amador, please.
Next presentation is entitled How to Trust a Bot, an RPA user perspective. And I think it's going to be presented by Rihan, who is already there, making very interesting questions. So Rihan, as soon as you would like, you have, let's say, 12 minutes for the presentation, 10, 12 minutes, and then the questions.
All right, so everybody can hear me, I believe.
Yes.
Yeah, great. So good evening, everyone who is attending this presentation. Myself and my co-author, Mo Wen, warmly welcome you for this discussion. So this is our work in progress in RPA trust and human perspective. The topic of today's discussion is how to trust a bot and RPA and user's perspective. We both are from Queensland University of Technology in Brisbane, Australia. So let me jump on the motivation behind this work. So I prior warn everybody who is from very technical background that there are no Greek letters, there are no architectural diagrams in this presentation. It is very management focused theory development work. So my apologies if anybody is getting hurt with this presentation. So let me start with, of course, organizations continuously look for ways and means and methods to optimize their resources and excellence in innovation. RPA is one technical solution amongst many in their arsenal. And of course, we have seen over the period of time, and I think yesterday's keynote by Mo, there is a huge demand and all consultancy organizations are showing a lot of promises, 30% growth, up to 7 billion valuation by 2025 by various consultancies firms. However, after 3 years of mainframe use of RPA, the results are coming and there are reports started to emerge with still a low adoption of 24 to 25% by KPMG's 2020 research work. The report also mentions about enterprise-wide acceptance and employee resistance to change as one of the two of the key barriers for RPA. There are evidence that 50 to 87% bot fails, and if they fail, they create a lot of issues in organizations. EY's 2019 reports looked at about 1,500 CIOs, and one of the key criteria they mentioned was the user trust in bots. So that was our motivation, and we start looking at why the human and bots needs to work together. And we believe that human and bots needs to share the processes and task responsibility. And if you look at another recent report by Forrester Research, the issues related to RPA failures in organization, that 58% impacts the customer services, 51% lower employee productivity, 51% impacted employee experience, and 48% impacted cost and revenue, and 44% actually increased employees' error rates. So Lee and C's work said that they argue that increasing controlling roles of IT artifacts, which in this case is bot, is going to happen in future. Bots are expected to take over a majority of mundane but very important process tasks, because we all from BPM background, we know that processes should not have unnecessary tasks, which are currently performed by users or humans. And bot performance is definitely vital for successful acceptance of what we call term digital colleague. So they have to work as a colleague. So our research question for this work was how trust is formed between human users and RPA technology, in this case, the bots. So we took a research approach, which obviously we start looking at whether there are any current research in terms of anybody looked into human and bot behaviors, and we couldn't find much of the literature in mainstream IS fields. So we looked at information system trust literature, and we selected 33 key papers on IS trust and build a priori model based on Myers 1995's IT artifact trust theory. So our primary data was purposive sampling. We selected end users from different companies in Australia and Sri Lanka. 6 in-depth interviews, 90-minute average, were conducted, and most of the users were from banking, finance services, and insurance BFSI industry in 2 countries. The theoretical lens, as I mentioned, was IT artifact and integrative model of organizational trust theories by Myers 95 and 1990. The primary data analysis, we use a 2-stage constructivist grounded theory-based design in terms of our explorative data, and we use primary data analysis tool as NVivo. So we start working with the definition. So at this point, we are using Myers definition of trust between IT artifacts. So our assumption and our belief is that so far we believe that a bot is an IT artifact, is a software artifact, which should we should be able to explain using Myers work. And we modify Myers model by increasing or including the contextual variable in his original work. And what we did was we looked at these 4 dimensions, which are abilities, which looked at the skills, the competency, and characteristics of the trustee. So trust, there are 2 elements we are using here. A trustee is the agent that is to be trusted. In that case, it is the bot, which is going to work with the human in parallel. And truster is the agent that trusts the other agent. In that case, is the human. So benevolence, of course, is the dimension that explains the perception of the trustee's intentions. And I think I forgot to switch on my video. That's all right, let's continue. And integrity was referred to dimension that explains trustees' attitude, the bot's attitude towards adhering to certain principles, policies, and procedures from the truster's perspective. And the context were any other variable which has an influence on the bot and the user's performance. In the 3rd column of the table, we use our basic constructs, which we question our participants. So in terms of explaining the abilities, we look at the responsibility division, information accuracy, and reliability factors. In terms of benevolence, of course, if you all know that bots are designed by a human designer, so we are looking at the benevolence from the designer's perspective. Is the bot's capability to access authorized data usage, the designer's benevolence in terms of how much designers are aware of the process complexities, user understandability, and of course the faith in designers' capability to explain complexities in a process and ability to design a bot satisfying the requirement of a user. The integrity levels, we looked at the predictability of the bot performance, how a bot can behave in a certain environment. We look at the confidentiality, security, and user authenticity concerns. And in context, we looked at the strategic needs of the organization, the rules, regulation, governance, and policy elements, and of course, the associated risks with the bots. Right, so moving on, let me, in the interest of time, jump on our conclusions and findings. At this point, we have not looked at the sub-factors explaining how to measure the user trust, which will be the future work. So we start with the contextual element. So let me jump into the first factor or first key dimension, which is the RPA or bot ability. So we look at the over expectations. Because of the hype created by various media and organizations who are, or units who are actually responsible to create or implement bot, users mentioned that they were expecting quite a lot of intelligence from their bots initially. And also because it was a insurance, banking, and finance industry users mostly from, the consistency of data was one of the key concerns. Another concern was, which leads to trust, was the task visibility. The users were quite intrigued that they were not very sure whether something goes inside a computer system and it comes out with the results, and they were not able to see the steps how the bot is performing. And that led to this perception that we don't know what's happening inside the black box. So these three elements have got a positive to negative influence, which we'll be defining in our future work again. The next level was the bot benevolence, or RPA benevolence in this case. So we look at the design effectiveness, how the PDD documents, which we call the process design documents, are designed and how closely they mimic the actual process. And second one was the end user engagement, which is the typical term, like how end users' inputs were taken into bot design. And we also look at the awareness of bots process complexity. So that was a very interesting one, because I think Leon's also touched upon this element as well, that whenever there were multiple processes involved, users were not very confident whether the bot will be able to handle access to different systems, extract data from different systems, and be able to perform. So they were not aware of the complexity elements of process. And the last one was the technology support, which was actually when the bot fails or hangs up and face an exception, who do they focus on? So how the technology support, the technical team were available when implementations of RPA was done in organizations. The third and the last element was the RPA, or the bot's integrity itself. So we look at the concerns. Yes, the data security concerns were quite an issue with most of the users in our sample. They were not sure whether a bot, they were scared that a bot can be hacked. They were not aware that a bot works in a very secure environment, and their concerns were that security breaches are possible. A lot of senior managers were quite reluctant, and they mentioned that they are scared to delegate their tasks to the bot. And one of the organization case was actually, they shut down their bot after 3 months of usage because they were too scared of the bot's performance, and they thought bot is doing everything incorrect. From the contextual level, we look at the organizational strategic directions. And we also realize and identify a relationship between fear of job loss. Those organizations who have got a very strong strategy, a good center of excellence, respondents from those organizations did not mention fear of job loss, whereas respondents where there was no strategic direction, people were using RPA as a good to have factor, or feel good factors, or industry because everybody else is using, so let's use it as well. The staff mentioned that they fear that organization can use it as a cost-cutting measure, which will end up resulting their job losses. The third element from contextual was the top management support for, and of course, it requires investment. It requires dedicated teams and that needs top management support and their vision. So most of the top management support was relevant to technology support and availability of resources and training and development investments. The fourth factors we identified was the data channel variation, and that really has an impact on the consistencies of data. Now it could be a very peculiar element related to banking, insurance, and finance industry, because the working model, operating model works with multiple channels. We have got franchisees and elements, etc., and they all produce different types and different quality of data. So multi-channel data variation leads to this consistency of data, which result into loss of user trust.
I'm sorry, Rihan, to interrupt you, but you should wrap up, please.
Yeah. And awareness of bot capability, and finally the industry pressure were the element. So in terms of our conclusion, we identified that quite a few factors we confirm already. We know from any IT artifact trust factor, for example, change management, mutual understanding, quality assurance of the bot performance, and data consistency, etc., etc. However, we also identified that the way organizations introduce bots differs and makes a lot of impact. Training of bot is a lot. In our case, in our findings, 95% training, it was mentioned as a criteria from a bot to move from production environment to operation environment. Designers and analysts skills matters a lot to lead the trust, and comprehension of complexity and end-to-end process interaction is important. One of the important factors we identified, the personification issue. Organizations who have given names to the bot and make it as a human being, it was a stiff resistance from their participants. They did not like the bot to have a person name, and they start perceiving that bot can have the same capacity as a human being. And of course, well-designed processes was the key, optimization was the key. It is limited because the data is small. As you notice, it's 6 interviews, expert interviews from the same industry. Future work, we're going to do more testing of our work. We are looking forward for a Delphi study to gain consensus on our initial model, and looking forward to a quantitative survey with a larger sample. So I left you with this interesting note that no bots were harmed in the making of this presentation. Thank you very much. And if you have any questions, please do shoot.
So thank you, Rihan. Can you stop sharing your screen? Okay. So now it's time for questions. I think there's a raised hand by Alexander Asatiani. Alexander, you can make your question.
Hello. Thank you for the interesting presentation. The issue of trust is something that I have been also thinking about in the context of RPA, but listening to your presentation, I sort of had this question. What is the main issue when we talk about the RPA trust? Because RPA is essentially quite transparent in the way it works. So it's not like those complex artificial intelligence or machine learning algorithms. It's not like a black box. And it works in a fairly straightforward way. It automates rule-based processes. So is the problem really the word robotic or a bot there, or is there something else in terms of the perception of the people? Because people do use the systems that automate or access data or do these other things that RPA does as well.
Yeah, thanks, Alex. And of course, is definitely a very interesting question. Yes, that was our initial assumption, that is an IT artifact. Just like an SAP system, it should be perceived by the human as is. But what you said was making a lot of sense as well, because when you put the term robotics, immediately most of the end user believe that it's going to have an impact on their economic and social and organizational well-being. Sharing responsibilities. So for example, one of the organizations which we were interviewing, the original idea is to actually release the staff from mundane tasks. But then the problem is that most people are happy with the mundane tasks. And when their job is taken over by a bot, they struggle and they feel threatened because they don't have a role to play. So at this point, our data present or reflect that trust issue is more towards the strategic vision, direction, and the way the awareness is created amongst the staff and the way the organization planning is done, and of course, like the new way of looking at the operations management of the bots. So that is what our stance so far. I totally agree on perspective. It is an RD artifact. People should behave just and take it as is. But when you have a bot next to you, which his name is James or Alexander or Syed, and this guy is taking and sharing your responsibilities, people are getting threatened. And they don't like it.
Thank you very much. Looking forward to the paper.
Since I think we are a little bit late because we only have 20 minutes for the next two presentations, I think it's time to pass to the next one. Thank you, Rehan, for your presentation and answers.
Yes,
so,
thank you. Thank you. And I think we could now move on to Jose's, Carmelo's and Jose's paper that is looking open source logger for the analysis of RPA. So please, Jose.
Okay, thank you. Do you see my screen?
Yes, it's okay.
Oh, okay, perfect. So thank you very much for your presentation, and I'm going to present the paper entitled Towards an Open Source Logger for the Analysis of RPA Projects, written by Jose Manuel López Carnicer, Carmelo del Valle, and myself. Well, this is the outline that I'm going to follow during the presentation. First, I will contextualize the proposal. Secondly, I will develop the related work that we have found describing their limitations. Thirdly, I will present the proposed approach presented in this paper. And finally, I will present a set of conclusions and feature work. Well, let's imagine a human process like managing the non-payment of clients of a phone company. They have to do too many operations like contacting the customer by phone calls or mailing, or even contacting a lawyer company if the customer doesn't pay. But well, this is a process that in some way they don't want to do because it is not their business. When this is a process that they want to outsource, giving their responsibility into a BPO company. So of course, the phone company has everything that it is needed to deal with this procedure. For example, mechanisms to access to the customer information, layer documents, etc. Well, then this company can access to the system through a secure connection, such as TeamViewer or Citrix application, for example. That limits your interaction with the application, so you can see only images. After some time, all the people do the work because they have learned as they have to work, and they have acquired all the knowledge for being using the application. So in summary, this is the process of a BPO context. We have a process that has to be outsourced. We have to train the people to develop this process, and then when they have trained it, they can start to work against the information system of the company. Well, at this point is where the RPA comes into action. RPA is a technology which allows you to interact with the user interface as a human would do. The idea is to develop robots that mimic the behavior of the human back office workers. And to do so, it is necessary to generate a user interface log that can collect all the information that the human back office workers are generating and process it to be included in the analysis phase of an RPA project development. Just in this point is where we are going to focus this approach. It is in the way of collecting and processing data generated from the one or more office positions. Okay, so this approach emerged from the collaboration between the Service Phone Company and the IWT2 research group, thanks to the development of the IFA project funded by the government of Spain. And at the first point, the Service Phone Company identified some requirements that are not typically offered by some common loggers, and that they are the motivation of this paper. Those requirements are the scalability level, for example, the number of computers that can be monitored at the same time without impacting the system, the method of sending the captured information to the user, the facility of processing data, either through a database or some data structure that can be processed, a log, for instance. And finally, the open source. That means the possibility of editing or complementing the features offered by the tool with new software or new features. Well, some available tools were analyzed in order to know if there exists any tool that cover all the requirements, and other ones more generic. Some of the one analyzed were the possibility of recording keyword events, mouse clicks and positions, or the moment of capture, among others. Well, with all these characteristics, we created a classification framework. These characteristics were analyzed for all the tools and were identified, resulting in the table that you can see in this slide. The way that we gave for each coincidence was 1 if the feature was covered by the tool, a half if it was partially covered, and 0 if it was not covered. And it is possible to know none of the tools cover all the requirements, that the most important ones for the company were not covered. So the primary limitations that we found was that most of the privacy was most of the software was privated, and it was very difficult to create a new development to adapt the results of these tools to our project. It is difficult to create a new development to improve the logger. The data preprocessing to be used by an RPA framework, it is difficult to manage. It is also difficult to use the application in a remotely way. And finally, it's not so easy to create new capture policy depending on the relevant information for the company. So considering these limitations, we decided to make an open source RPA logger to bring the community the possibility to make all these operations and customize them depending on their needs. Well, this RPA logger is based on a set of elements. The first one is the endpoint logger. The endpoint logger is focused on gathering enough information for future RPA analysis. It captures right now the position and at the button time of the mouse clicks, the keystrokes and the screen captures, and it provides 3 mechanisms of extension. The first one is based on the capture extension for a specific context. The logger can be extended with scrapper components, for example, word scrappers or so on. The capture policies that are differentiated into 2 types. The first one's the policies related to the capture mouse and keyboard events, and the second one related to the capture of screen captures. So the capture and the one defined for capturing the mouse and keyboard events is the defined one is to capture 1 event per mouse click or keystroke, and the screen capture is related to capture 1 image or per click or keystroke. So it is the ones defined right now, but it can be extended. And finally, the send policies data to the central server. So the current policy sends the event once it occurs. However, in a context where network restrictions apply, a common policy would be to send all the events at the end of the day or something like that. Like I said, it is configurable. For sure, we want to monitor not just one endpoint, but 1 or more in different computers. So in this sense, what we do is to send the information to a central server. The central server is in charge of storing all the events associated with each monitored computer. In addition, the heavy processing is performed to extract information from the events to be more useful for future RPA analysis. For example, comparing the similarities between images to detect which ones correspond to the same activity by an efficient bitwise comparison between images fingerprints. It means short hashes which are obtained from each image in a deterministic way. So the data processing in the central server will be performing on demand. At this point, the information being collected does not have to be processed at runtime. This way of processing the information can be beneficial to prevent database overloads by avoiding unnecessary iteration. So this is, let's think about a single process. For example, a teacher that has to consolidate the results of the exam that she marked on her institution website. So this feature of this slide illustrates a simplified log with some of the most interesting files to be considered. Among them, a global identifier, the identifier that identifies which computer the capture came from, the timestamp of the capture, the action, and so many other things that we have not showed at the image, and also the window where the actions are executed. So summarizing, remember that our start point is based on the collection and processing of information related mainly of an outsourced process, and also there are some tools that allow to do that. They do not cover all the requirements that we need, and the most of them are not open source, so we decided to create a new tool. We have established the basis for an open source logger for RPA projects that is composed of two elements: a logger capable of collecting information from different events and computers and sending it to a central server, and a central server that is responsible of processing this information and converting it into an enriched log so that the data can be processed data. So at this moment, we have an alpha version of the tool, but it is not yet ready to be published as an open source project to continue its development. So then our immediate works and finishing the development of a beta version of the logger, and also go in depth in the definition of the requirements of the proper tool, preparing the data for processing by data mining techniques, and finally developing more policies to manage the data processing, and also the policies that manage the central server. So it is all from my side. Thank you very much for attending this presentation. I don't think if you have any questions. Sorry if I have been too fast.
No, thank you, Jose, very much for the presentation. So I think we have time for one question. Is there any questions? You can put in the chat or raise your hand. Well, at the moment, I'm not seeing any questions. I think you had very comprehensive presentation, and you have done a great job. Yes, so you already mentioned future directions. So what are you going to do next? What's the next step?
Yeah, as I said, we have developed a tool right now, but it is not. It is a very initial phase. So right now we are trying to make an stable beta version of the application and publish it as an open source project. And we hope to cover all the things that I have been mentioning. For sure, we have a collaboration with the company that will let us retrieve a lot of data. So we will, when we have already developed the tool, we will ready to create a very big case study.
Okay.
This is our immediate future work.
Thank you. I think that sounds very great. So maybe next year we can also hear your empirical results.
Yeah, for sure.
Okay. Hey, thank you so much. So I think we need to hurry up to our last presentation now. So please.
But not least, Next presentation is called A Framework for Evaluating the Suitability of Process Activities for RPA, and I think it's going to be presented by Christian Bellman. Christian, are you there?
I'm here.
So whenever you want, let's say you have between 10 and 12 minutes.
Okay, thank you very much for the nice introduction, and welcome everybody to the presentation of our conference article, A Framework to Evaluate the Viability of Robotic Process Automation for Business Process Activities here at the RPA Forum. My name is Christian Bellman, and I'm going to present this article written by myself and my co-authors Matthias Stierle, Sebastian Dunzer, and Martin Matzner. And we're all from the FAU Erlangen-Nuremberg and the Chair of Digital Industrial Service Systems. So the outline of this presentation is as follows. I will start with an introduction to the problem and then the solution proposal we have for it. Moving on to the related work and the structured literature review we conducted before moving on to the artifact we developed based on the insights. And then moving on to the evaluation, where I discussed the evaluation approach as well as the results from it, and concluding with our contributions to limitations and also the future research possibilities. Coming to the introduction. So the state of technology is continuously advancing, resulting in shorter intervals to scrutinize whether tasks can be automated or they rely on human execution. And the recent rise of robotic process automation challenges the status quo once more and also further blurs the boundaries between human-computer interaction. RPA, robotic process automation, automates repetitive and monotonous tasks by configuring software robots to mimic the actions of the user on the presentation layer. So organizations are now hoping for RPA to lead to an increase in time for employees to focus on more value-adding tasks, or also to cut costs for eliminating time spent with information systems and data transfer. Furthermore, companies also expect RPA to improve the quality of the work, eliminate possibly human negligence, and also increase the reaction time to around the clock. So while the benefits for RPA seem evident, the question still remains as to why there are currently only a few success stories of RPA adoption. And one of the biggest challenges identified for successful RPA implementation is the selection of suitable processes or process activities for RPA. We've also heard this yesterday in the keynote from Professor Mo Win, that there is a lack of unbiased guidance on RPA suitability assessment and process selection, and this is the foundation for this work. So the methods available to date mostly offer high-level decision-making support, and they focus more on the profitability rather than assessing whether RPA is really viable for the processes or tasks. The objective of this work is therefore to offer practitioners a process characteristic evaluation framework, including a set of criteria and exemplary evaluation metrics. And the method to achieve this objective is to conduct first a structured literature review, use these insights to create a framework, and then evaluate this framework through process mining and by applying it to a real-life data set. Coming to the related work and the first step of this process, so to obtain a comprehensive list of potential process characteristic evaluation criteria, a literature review following the guidelines proposed by Webster and Watson was conducted. And in order to develop the framework, we first had to answer the question whether, what are the characteristics of a process activity or a set of process activities that facilitate viable robotic process automation. And for an exhaustive review, we searched sources in the databases Scopus, Google Scholar, and IEEE Export Digital Library. The identified criteria were then compiled, checked for redundancy, listed in the concept matrix that relates the criteria, as you can see here on the slide, with the source articles, and also visualizes the acceptance and relevance through the number of mentions. So to support practitioners in evaluating the viability of RPA for process activities, we summarized the findings of our literature review in a framework. coming to the artifact. So this table visualizes the process characteristic evaluation framework to be developed. It consists out of 3 dimensions. We have the perspective, criteria, and an exemplary evaluation. So the perspective is grouping related criteria. The criteria is there to evaluate the RPA viability. And we also give an example to how can a practitioner use this criteria to assess it. To describe this framework a little bit more in detail, the task perspective refers to the execution of process and process activities. And the criteria listed under the time perspective focuses more on the duration and the frequency of processes and process steps. In many processes, information is processed in multiple systems, and therefore we also have a data perspective which resembles the structuredness of data. And additionally, the system perspective poses the interaction with interfaces and also the stability of the information systems in use. Last but not least, we have also human perspective, which deals with the human-computer interaction and obviously focusing on the human. So to demonstrate how a practitioner could apply this framework in practice, I will use the criteria standardization of the task perspective, so the first criteria in this framework. So first, the description. What is standardization? It refers to a process's degree of structure. In a standardized process, every process element is unambiguous, and the execution order of the process remains the same in each process instance. As a result, in an ideal world, every stakeholder receives the same outcome from a standardized process, and we therefore examine the execution order and the number of process variants to measure a process's standardization. So in practice, we can, for instance, analyze the predecessors and the successors of the process of interest. And ideally, the order of execution remains the same and also equals to the desired process flow. In the next step, we evaluated this framework by applying it to a data set, coming to our evaluation. So the evaluation focuses on event logs generated through process-aware information system, and we aimed at an objective evaluation by using a publicly available data set to show the applicability of our framework. And as I already mentioned, we determined process characteristics with process mining software. So we test the framework, as I said, for the applicability in a practical environment. The candidate process, also shown here on the slide, describes a typical purchase-to-pay process of a multinational coatings and paints enterprise. And it covers the typical steps from creating a purchase order item to the clearance of the invoice. And when we were examining the event log, it revealed that traces, including the manual activity change quantity, that they took a month longer on average. And for this and other reasons, we selected change quantity as our process step of interest and applied our framework to evaluate this activity for RPA viability. The results of this evaluation are that 8 of the 13 criteria could be evaluated with our approach. We also demonstrated in our work that the framework aids in determining characteristics of processes or process steps. And although we could not assess all of the criteria in our case, the evaluation provides important insights which clearly can give an indication of RPA suitability for this specific process activity. And we also tested the framework with a real-life data set showing its usefulness and the applicability in a real example. However, the application of our framework also revealed some deficits when validating the efficacy and validity through process mining software. First, missing attributes such as missing timestamps in the event log impede the possibility to assess typically easy to assess criteria like the execution time or the execution urgency. Second, the possible lack of information about exceptions, whether they're caused from a system-related issue or a human error caused issue. And third, crucial information about the interaction on the user interface is missing and also prevents the examination from criteria such as determinism, interfaces, or also the number of systems. So coming to the conclusion and the end of this presentation, the contributions of this paper are that we developed a framework to evaluate the viability of robotic process automation for business process activities. We offer a guideline for practitioners to assess whether a process or a process activity is viable for RPA or not. The limitations are that we tested this framework with only one data set, that not all criteria could be evaluated, and we made assumptions about the data set which also limit the significance of the results. The outlook and future research opportunities are that we can further validate the framework, also to conduct expert interviews to assess the usefulness of this framework, and to do research on the quantification of criteria. With this being said, I'm at the end of my presentation. Thank you very much for your attention. And do you have any questions?
Okay, thank you, Christian.
Thank you.
Stop sharing.
Could give the applause.
For the clap.
Yeah.
It's that we're 5 minutes late, 6 minutes late. Okay, so thank you very much for your clear presentation. We have time, I suppose, for one question. If anyone wants to make a question, please raise your virtual hand so I can see you in the list of attenders. All right, let me check the chat. Okay, so it seems that everything was so clear, Christian, that nobody has any doubt about your presentation.
Everybody's ready for lunch already.
Probably. So since it's almost 13. We were supposed to finish at 12:50. I think it's time to finish this session. So please, Nina, could you proceed?
Yes. So thank you, Christian, and thank you, all of you presenters. I'm sorry that we are a little bit late about the schedule, but I hope that later, if you have any questions, you can, of course, send those to me or Amador or directly to the presentators. So I wish you a nice day ahead and want to thank you all for participating in this session. Thank you.
And please, if you can call physically to Seville sometime, do it. You're missing a great city. It's not because it's my city, but everybody knows that. You know? So, bye to all, and I hope I will meet you somewhere, someplace physically when all this horrible virus situation is solved. So, have lunch and goodbye to everyone.
Yeah. Goodbye.